Hi guys, welcome to my presentation on the epsilon and delta definition of a limit. Before we approach any of these problems, we have to define what the epsilon and delta definition is. For this, we use the definition that was given in our notes of the precise definition of a limit. It reads, let f be a function defined on some open interval that contains the number a, except possibly at a itself. Then we say that the limit of f of x as x approaches a is L, and we write the limit as x approaches a f of x is equal to L. If for every number epsilon greater than 0, there is a number delta greater than 0, such that if the absolute value x minus a is greater than 0 less than delta, then the absolute value of f of x minus L is less than epsilon. For these problems, we're going to use the bottom notation definition to solve these examples. Before starting this example, I'm going to write down the epsilon and delta definition of a limit. The problem reads, when demonstrating that the limit as x goes to 0 for x plus 4 equals 4 and epsilon equals 0.3, which of the delta values suffices? With the information provided, I'm going to input the information given into the formal definition. Since the value of a is equal to 0, we can just leave it as the absolute value of x for the interval of delta, and then we can input the information for the other side of the definition for epsilon. What we do now is try to solve the inequality for epsilon so that we can create a relationship between both sides of the definition. The 4's cancel out, which leaves the absolute value of 4x is less than 0.3. We divide 4 on both sides so that we get the absolute value of x is less than 0.3 over 4, which is equal to 0.075. Since both sides of the definition are equal to the absolute value of x, we can now set both sides of the definition equal to each other. We can write this as 0 is less than the absolute value of x, which is less than delta, and we can now make this equal to 0.075. The value 0.075 is the largest value for delta. This means that we can rewrite this as 0 is less than delta, which is less than or equal to the value of 0.075. With this new interval notation, we can now find how many of the 4 answers given applies to this example. Delta equals 0.025 fits within that interval. Delta equals 0.00565 also fits, and delta equals 0.075 also fits within that interval.